Wood is primarily made up of cellulose, lignin, hemicellulose, and extracts. At present, cellulose can be fully utilized, but the other fractions mostly end up being incinerated. In a smart bioeconomy, it is vital to create high-value products from all the components of wood. Indeed, lignin, hemicellulose, and the inherent properties of the extracts offer tremendous opportunities that researchers are exploring. The problem in utilizing lignin has been its poor water solubility and difficult chemical structure, which even varies from tree to tree.
Lignin chemists have been arguing about the exact lignin structure, so someone might say that it's actually not three-dimensional, it's like linear in the nature, but when you extract it from the pulping, then it reacts within the lignin and with the other lignin molecules and makes this three-dimensional structure. So actually this argument has been going on in the lignin community for a very long time. So I think that if you can't even agree on the structure, that might be one reason why it's difficult to utilize.
Professor Monica Österberg has developed an ingenious way to bypass this problem. Using a simple method, she is able to reform lignin from irregular shapes into spherical particles. This causes the lignin to behave in a predictable way. And best of all, these nano-sized lignin spheres can be made from the cheapest lignin, which is an abundant side stream of pulping.
Using this craft lignin that is most available, so it's a cheap raw material, and then we can just dissolve it in an organic solvent, and then when we put it into an anti-solvent, the water, they spontaneously self-assemble into the spherical particles.
Self-assembly thus creates perfectly shaped spherical particles.
They are all perfect spheres. That's how nature wants it. It's the lowest energy form. I mean, if you go to nature, you're not going to find squares or stars. The sphere is the minimizing the surface area, very simply. So that's the form. That's why water droplets are also spherical and not square.
Nanomaterials are usually very expensive to produce. However, these nanospheres are surprisingly cheap and easy to make.
The process is very cheap. So when we have calculated on the cost of the process, I think we are below €1 per kilo. So, and that's a lot of the cost comes from the lignin. So the process is actually just dissolving lignin and then precipitating it in water.
Lignin nanospheres can be utilized in many different applications, replacing fossil-based raw materials for adhesives and cosmetics. As a coating, nanolignin forms a breathable, water-repellent, and decay-resistant wood preservative.
It will protect the wood from sunlight, and since it's hydrophobic also, it protects it from water, and because of that also it protects it from stains like coffee or wine, and it's also solvent resistant.